So let's focus on one of the logical equivalencies. Well, double negation laws. You've probably seen that before, but anyway, but still, in this, the overall form of this is having a P or a P naught, or your negative P or your negated P, that's going to end up being a true. The other one is this time it's an and. P or not P is going to equal a false. So now again, we could do the truth table on this to prove it, which I suggest that you do. But here it's telling us, hey, no matter, it's going to be that way. So there's a couple of terminology things with this as well. A tautology is a proposition that is always true. And you've seen these before. The or symbol is going to be really the key in this. So it's easy to find, frankly, if there's a true in there, the rest of the items or a single item in there has ors in them, then you know the whole thing's going to be basically true. And that is a tautology. The other one is a contradiction, where it's always false, just that. You're really looking for the and symbol, and remember, if everything has an and or the and's left and there's a false somewhere in it, then the whole darn thing is false. So just that. And then a continued C is basically a mix of those two different items. Well, and it sounds familiar in our programming where we could have those type of things. It's going to be a mixture of trues and falses when it comes into that type of equation. Then I wanted to show you at the very end here negation in use when we're doing our truth values, not our truth tables, but truth values, is that what you're going to end up seeing is you're going to see some work that we're working on, and it's going to have equivalency to some value. But then what's going to happen, I'm going to show you, hey, we got rid of the highlighted negatives, the double negatives here. We got rid of it, and I'm going to explain what's happening below that or happening at that point. So just showing you some previews of how our negation is going to work and how exactly we're going to be using it in our equations here that we're going to start reducing.